Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Umar Muhammad Yusof. This is my research proposal for the research methodology course, which is the title is Comparing Large Language Models and Prompting Strategies for the Stock Market Sentiment Analysis, supervised by Prof. Dr. Azlan Muazzin. Over the few minutes, I'll walk through the problem, my research question and objective, what the literature says, my methodology and contribution I expect. Here the roadmap. First, the problem and what is method. Then my research question and objective. Next, what the literature said and the gap I'm filling. After that, my methodology. And finally, contribution I expect the study to make. Next, the starting point is simple. Stock price don't move only on the numbers like earning and volumes. They also react to the language, news headlines, corporate feelings, and posts on social media. The problem is that this that now arrive in volume far too large to read by hand. Large language model changed that a model like GPT-4 or LLAMA3 can read a single headline and judge whether it's good or bad for a company. So the practical question becomes which model used with which prompting strategy read that sentiment most accurately and most cheaply. Next, but the literature give conflict advice. First, which model win is uncertain. Fine-tuned Fernbird often reach the higher accuracy, yet GPT-4 close the gap once it given a few work example. Second, prompting does behave predictable. Few shot can help, but chain of thought sometimes give no benefit and even make result worse. An effect some author call overthinking. Third, the studies do not line up. They use different data set metrics, and they realize and then rarely measure cost or reproducibility. The result is that anyone wanting to build a financial statement system has no clear, reproducible guidance on the best model and prompt combination for the course. Next, from that problem, I set 3 research questions, each pair with an objective. Research question 1 asks, which model and prompt combination classify financial statement most accurately? The objective is to build a reproducible framework and compare them on sentiment classification. Question 2 asks how well LLM drive sentiment predicts whether a stock move up or down the next day, and which combination does this best. Question 3 asks what trade-offs appear once accuracy is weighed against cost and reproducibility. The objective there is to examine those trade-offs and give evidence-based guidance. Next, a quick word on scope. In the scope, 3 models, Fernbird, LLAMA3, 8B, Instruct, and GPT-4. 3 prompting strategy, 0 shot, few shot, and chain of thought. 2 tasks, 3 class sentiment classification on the next up and down movement, next day up and down movement. It used only public data, focus on US listed equities in the S&P 500 and English text through a reproducible Python pipeline. Out of scope, no live or high frequency trading system, no non-English text, and no financial advice. This is methodology comparison, not a recommendation to buy or sell anything. Next, the literature groups the models into three families. Domain-specific model like Finbird are tuned for finance and cheap to run. Open source general model like LLMA3 can be downloaded and run on your own hardware. And closed source general model like GPT-4 and powerful but reach only through a paid API. Alongside the models, there are three prompting strategy. Zero shot givens, zero shot gives just an instruction. A few shot adds a few word example and chain of thought asks the model to reason step by step before answering. The key insight is that it's pairing of model and prompt together that governs accuracy, cost, reproducibility. Next, pulling the literature together, there are clear and reachable gap. One, the evidence on which model family is the best is contradictory. Two, the effect of prompting strategy is unsettled. Three, comparison are fragmented, built on different dataset and metric. So they can't be lined out. Four, the reproducibility of this LLM study is rare, rarely examined. And five, the accuracy versus cost trade-off, which really matters in practice, is rarely quantified. My study's response is to run one controller, reproducible comparison of all three models across all three prompts on the same public data and metric. And crucially, to measure cost reproducibility alongside accuracy. Next, for the method, the study is organized around the design science research methodology of Perth and College from 2007, a framework widely used in computer science for the project and build, and then evaluate an artifact. Here, the artifact is reusable evaluation pipeline. The design is quantitative, experimental, and cooperative. This CRM has 6 activities and each map onto a stage of my study: problem identification, answers, the mixed finding. Finding objectives is the fair comparison framework. Design and development is building the pipeline of models and prompt. The demonstration is running it on public dataset. Evaluation is measure accuracies, cost, and reproducibility. And communication is reporting the finding in this station. Next, here exactly what GAT compares. 3 models against 3 prompting strategy. Finbird is the fixed domain specific baseline, it take no prompt. So one configuration LLMA3 instruct and GPT-4 each run under all 3 prompts, zero shot, few shot, and chain of thought. That give a clean controlled set of configuration. Everything else in held constant, the same test set, the same metric, temperature set to 0, find model vision, and repeated run. So any difference we see is due to model and prompt, not to the chain or setup. Next, the study draws only on public dataset. The financial Parabank, Press Bank, about 4,800 expert level sentence is the primary benchmark for sentiment classification. The Twitter financial news statement dataset, roughly 12,000 finance tweets. Test performance on a very different noise style of text. Next, performance is judged with standard classification metric: accuracy, precision, recall, the micro average F1 score, and the Matthew correlation coefficient. The last two being robust to class imbalance plus confusion metric to surface systematic errors. To check that difference between model are real and not just not just change. I apply pair statistical tests such as MC-NIMA test, and alongside accuracy, I log cost reproducibility. The token process and API cost, the inference time, and hardware, and the spread of result across repeated time. If I report any long short hit rate, yeah, it purely a diagnostic, never a trading recommendation. So what we study deliver two contribution to the domain control reproducible evidence on which model and the prompt combination best read financial statement and predict next day movement, and a clear judgment of whether any extra accuracy is worth an extra cost. To the methodology, a reusable evaluation framework that compare model families across prompting strategies under identical data and metric, which cost and reproducibility built in. That, but and that framework can be extended to tax classification well beyond finance. Importantly, this is framed as computer science contribution in NLP and machine learning. Finance is simple the data domains. It's simply the data domains. That the proposal, to recap, is controlled reproducible comparison of three models family across three prompting strategy on public financial data, measuring not just accuracy, but also cost and reproducibility.